So, good evening, everyone. I'll start the session. People are still joining only. So, is my voice audible? Am I audible?
Yes.
Okay, thank you. So, I'll start with week 2 and discuss some problems there. So, first, I'll be speaking about the last previous run courses assignment 2 for week 2. So, after that, I'll go through some R programs related to week 2, and then with the time permits, I'll start with week 3. Okay, so this is going to be the contents of today's live demonstration. So people are still joining, so I there will be some interruption in between, and so I'll just check the recording and everything. Okay, so let's start with the questions. So I'll just put different highlights of week 2. Okay, so week 2 is like you are introduced to metrics. Then metrics means like introduction of metrics, independent and dependent variables, then solving linear equations, and then like a geometric view of the linear algebra where you had seen vector, norm, orthogonal vector, basis vector, etc. So that was the highlights of week 2. So just I'll simply rush through the basic highlights. So what is a matrix? It's an organization of data into rows and columns. So rows means like it will be, if you are getting the data set, it will be like the samples of the data set, and columns will be like the variables or features. Okay, for example, if I'm taking a biomedical data set of 1,000 patients, then these will be the columns. So serial number, weight, height, and age. So 1 to 1,000 shown here will be the samples or rows, and serial number, weight, height, and age will be the columns. Okay, so these will be having different values. Now, independent and dependent variables. So, independent variable is a variable that store unique information, and dependent variable is the variable formed by the combination of already existing variables. Okay. So, one example for a dependent variable, I've shown an example here. So, there is the height, weight, age, and BMI. So, just can you tell me the relation of BMI with weight and height? Yes. Yes, Shiva, you're right. So it's like weight by height square. Okay. So according to that, you can see that the column here represented for BMI is actually weight divided by the square of the height. Okay. So this column is dependent on weight and as well as height. Okay. So it's an example of a dependent variable. Now, rank and nullity. So, depending on rank and nullity, you might have seen different um, questions in your assignments. So, rank will be like the number of independent variables or samples, and nullity will be like the number of linear relationships which are available in the um, matrix. Okay, so every time nullity plus rank will you give you the total number of variables. So for example, in this particular matrix, the number of variables will be 3. The rank of A in this matrix will be like 2, because you can see here 1, 2, 3 is the first column, 2, 4, 6 is the second column. So there is a relation between them. So the rank will only be 2, and then the nullity of A will be 1. So the in this case, the column 2 will be like 2 into column of 1. Okay, so that is the case. So we'll just go. Yes, we will move on to certain questions here. This was given in the last previous run course. Okay. So first question is like trace of 3 by 3. Sorry,
What is melody?
nullity. I didn't get you.
Yes.
You're not audible. Assignment. Can you type in the chat window? Okay, nullity is the number of linear relationship which is available in a matrix. Okay, so here you can see if there is a linear relationship in a particular matrix, and if there are number of columns which have a linear relationship, then it's known as the nullity. Okay, so here you can see in matrix A there is 1 2 3 first column, 2 4 6 second column. Okay, so here column 2 is 2 into column 1. Okay, that means that there is a linear relationship between these two columns. Okay, so there is one linear relationship, so the nullity in that case will be 1. Okay, wherever the linear relationships are there, then the rank will be reduced also. Okay, so whenever nullity equal to 1, then the rank of that matrix will be 3 minus 1, which is 2. Okay, is that fine? Is that fine, say Phoenix?
Yes, ma'am. Yes, ma'am. It is clear.
Okay. Okay then. So I'll move on to the next question. Then okay. Trace of a matrix 3 by 3 matrix is 9. Then EA has a eigenvalue. Okay. So can you just I have just written the answer also. But for I mean you can say like what is the trace of a matrix? Trace of A will be equal to the sum of its eigenvalues. Okay, so lambda 1 plus lambda 2 plus lambda 3. So first I'll be discussing the theoretical part of these questions, and then we'll see with the R. Okay, so people are still joining. So can you tell me that lambda 1 is 9, right? Lambda 1 is 9, lambda 2 is 9. You don't know what is lambda 3. So you can find out that lambda 3 is equal to minus 9, right? Sorry, I didn't see some questions. Do we have to solve the system? Is in the any questions you were asked to find the null vector? Yes, you can do that. And at the end of the session, I'll show you a resource you can look at. Okay, and even in R also, if you put null space of some vector, you'll get the value. Okay, Shiva. Okay, so I think that's clear. Okay, so then lambda 1 plus lambda 2 plus lambda 3 equal to 9. So lambda 3 equal to minus 9. Okay, so what will be determinant of A? Determinant of A will be the product of the eigenvalues, which is equal to minus 729. Okay, so this is an easy thing. Okay, so the next one, which of the following vector sets is or are orthogonal? Okay, I'll do the first one. Okay, you try all the things and try to find out the answer, okay, from that set of options. Okay, so you can, this the first one is like 5 minus 2 3. So how do you find the dot product of something? Sorry, How do you find whether the things are orthogonal? Have to find the dot product. So dot product means like v1 transpose v2. Okay. So first you have to find v1 transpose v2, and then you have to see whether it is zero. That means that your particular vectors are orthogonal. Okay. So can you find out? I'll just do the first one. So first one, v1 transpose will mean that it will be 5 minus 2 3, and the second one, v2 is like minus 2 4 6. Okay, so the answer will be minus 10 minus 8 plus, sorry, minus 8 plus 18. That will be 0. Okay, so first one we are getting the value as 0. Then second one, can you tell me what you are getting the answer as? Okay, yeah, 130. Yes. Third one, third question. Yes, that's right.
Ma'am, zero.
Yeah, second one is not orthogonal. Yeah. Then fourth one, Aditya, you are saying for B, the B option, right? Okay. Second one, 130. Okay. Then fourth one, what's the answer? What will happen there? Okay. So yeah, that is true. Then I mean the number of variables there is less actually. Okay, number of columns is less. So then, so your answer will be like the option A as well as option C are orthogonal vectors. Okay, so we'll move on to the next question. If any doubt is there, you can ask. Next one is A equal to 7465. We have to find the value of a raised to determinant of a raised to 5 minus a raised to 4. Okay, so I've just given the answers here. Like a raised to 5 is calculated like this, and a raised to 4 is coming like this. Okay, and the total will be coming in this way. So here you can see what is happening here. A5 minus A4 is singular. So if it's singular, then the determinant of a raised to 5 minus a raised to 4 would be 0. Okay. So we'll see the operation of this in R also. So I hope this question is clear. Just you have to find the matrix multiplication. I mean a power of 5. Okay. So this is the answer for that. Next question is like, I hope you're able to follow it. Okay. So next question is finding the inverse of matrix. Okay. So can you tell me what will be the answer? 1 3 5 2 6 10 3 9 8. Can you find the inverse?
Ma'am, inverse will not exist.
Yes. So why? Why does it not exist? Can you tell me the reason?
Ma'am, because the columns are independent.
Yeah, the columns are dependent. Okay, that is the reason. Okay, so which of the following is true about orthonormal vectors? Can you tell me what is true? You can put in the chat window also, anyone. So, what is the condition for a vector to be orthonormal? 2, 3, 4. Okay, 2. What is option 2? All orthonormal vectors are orthogonal. Okay, right. Then two vectors are orthonormal to each other if the dot product is okay. And orthonormal vectors are orthogonal. Yeah. So the answer will be like if you are asking like multiple answers are asked, you can tell 2, 3, 4. But if it's not asked like that, then the most uh, clear answer will be like the fourth one. Orthonormal vectors are orthogonal vectors with unit magnitude. Okay, here unit magnitude will come. Okay, so what is the answer? Next, which of the following sets of column vectors form a basis for r raised to 4? Okay, this also I think you can find out easily. What is the problem with first option? First option, what does it do? Previous slide. Okay, Sandeep, what's the problem in the previous slide? Okay, is it fine? Okay, okay. So, which of the following sets of column vectors form a basis for R4? Okay, so this is like, can you tell me option A? Can you find out the problem with that option A? Is there any problem with option A? This is option A actually. Okay, this is option A. Okay, like basis is like basis vector actually. I think I'll show you. I'll show you a resource for that. Mm, okay, wait. Let me just see. Mm, okay, so I think you can read from here. Mm, no, this is different. Okay, so you can see here. This one you can read. Okay, I'll share this one later. Okay, so if they have to form a basis, first thing is like you'll have you'll should have the number of rows, I mean number of columns which are like equal to the number which was asked. Okay, so if it's like R4, basis in R4 is required, then you need 4 columns. Okay, then the next thing is like they have to be independent, they have to be independent rows. Okay, so I'll share who's that Phoenix, I'll share this resource to you. Okay, is that fine? You can read through it, and I think it was mentioned in your sessions also. Okay, yeah, it'll also come later in our slides also. Okay, so first you can see with the things that I've told you, can you tell me what is the problem with option A? Full rank? No. Anyone else? Basis vector columns are independent. Yeah, columns are independent, but there is one problem with that matrix. Basis, you know, if you want to form a basis, you want to have that. Wait, mm, okay, just look at this option. How many rows and how many columns are there? Yeah, it should have 4 rows. Okay, so first thing is like, I mean, to form a basis of a of a matrix, what thing is like, first you will look like, you have to remove, if you have a vector, you have to remove some redundant columns from the vector, and those, all those vectors which you will be forming should be linearly dependent. So in the first option, like Soundriya said, it should have 4 rows. Here only 3 rows are present. Okay, the all the things are linearly independent, but one problem is there, like that it's not, it is not having um, what you say, it's having 3 vectors only. Okay, if you can see that. Okay, now in the next option, I am just going to option C, so you can see like, you can tell like, uh, wait, I'll just put in slideshow again. So in the first case, here you can tell like there are 3 independent rows only. That is the first problem. That's the problem with the first thing. Then that is a problem. Okay, so for second, option C, I'm taking next. Can you tell me the problem with option C? Mm, okay, and Isha, can you tell me why did you think that our answer is C? Yeah, Soundarya, that's right. Yeah, there is dependency. So in the second one, the problem is like, okay, so Isha, you look here, okay. So it's like option C has a problem because what is there? Yeah. So here, who has raised a hand? Okay, you can speak up. Okay. So I think no answer. So option C's problem is like there are linearly dependent columns. Okay. So here you can see like all these things. There is only one linearly independent vector. Okay, everything else is like dependent. So you can see here, first, I mean row wise, you can see here what is like 1 into 6, 14 into 6, 2 into 6, 6 into 6, 36. Okay, so first row, I mean second row is equal to 6 into first row. Then the next one is like, what is 1 into 14 into 11? Can you tell me?
154.
Yeah, so I mean 154, then 22, and 6. So third row is like 11 into first row, and fourth row, if you see, it's like 4 into first row. Okay, so in option C, column wise, yeah, what you told is right, but you can see, you have to see row wise also. So the first, like row 2 is equal to 6 into row 1 in the C, then row 3 equal to 11 into row 1, and row 4 equal to 4 into row 1. Is that right? So all these cases means that there is only one independent vector is available in that case. Sorry, one independent vector is available. Okay, so that is the case why you can't form a basis with the option C. Okay. Now option B, can you tell me what is option B? Can you form a basis with option B? Only thing is like you have to have 4 number of rows and columns. Then your all your vectors should be linearly independent. Okay. Okay, I'm not seeing any answers. Can you tell me? Everyone, can you tell me how's option B? Can you form a basis? Can you tell me the reason, Sandeep? Does it, how many rows and columns are there in option B? So in option B, it's like 4 rows are there, 4 columns are there. Okay. So is there any linearly dependent rows? Yeah, it's 4 cross 4. Yeah. Any linear dependency? Yeah, there is linear no linear dependency. So you can tell that option B is the right answer. You can form a basis vector with option B. Okay. Is this now clear, Phoenix? What is basis and all? You can just go through. I'll just share you some resource right now. You can click that also. I mean, check with that also. What is no? Why many people have put no? Can you tell me? Phoenix, you still didn't understand.
Got it.
Is it okay? I mean, okay, understood. I just lost the track of the chats in between. That's why. Sorry. Okay, so that's about in R2 into 2 plus 1. No, with any vectors, is there any dependency? 2R2 plus 1 is linear, or is it linear? Is there any other, I mean, does it have any relationship with any other vector? Aditya? I mean, it's not like 2R2 plus 1R1 like that. There is no linear relationship between two variables. Okay. This is like, it might be like 2R2 plus 1. That everything is like that. I haven't checked that right now. Wait. Plus 1. Okay, that is also right. No, Aditya, it's not like that, right? What's the answer to this question? Answer to the question is B. Okay. It's not, R4 is not like 2R2 plus 1, is it?
Well, I think you said that if there is a condition that the R2 is R4 is equal to R2 is equal to plus 1, so that it will be the
You're
solution
not
between.
you're not audible to me. Your voice is not clear. Can you type? Aditya, what have you? Are you asking like a question, or are you telling that there is linear dependency in the second option? Okay. If there is linear dependency, you can't form the basis vector. You have to see if there is a dependency. In that case, it will be like you can't form the basis vector there. Okay, is it clear? Okay, yeah. So next one, lambda 1 given like 1, lambda 2 equal to 2 be the eigenvalues, and one vector, two vectors are given, 2 minus 2 transpose, and then b2 equal to 3 comma 1 3 1 transpose be the eigenvectors of a real matrix A. Then let B be a projection matrix B equal to v1 comma v2. Okay, so have you learned what is a projection matrix? It is something which is very useful in data science actually. Okay, so what do you mean by a projection matrix? Anyone? So it's simply like, it's like a vector space projection of a vector to a subspace. Okay, so in this particular case, it's like we have two vectors here, eigenvectors of a real matrix A. So if it's given like we have a real matrix A. So if A is given, so we have, mm, just wait a moment. So if there is a real matrix A, and then its eigenvalues are given as eigenvectors are given as v1 and v2, then you can form the projection of the um, projection matrix as like this. Okay, you can put v1 v2 like that and you can form it. Okay, so here v1 is like 2 minus 2 and 3 1. So this is like b, this one is like the projection matrix. Okay, now what is the question is like compute b inverse ab. Okay, so that is what we have to find here. So B inverse AB. So I'll start with, like, I have given the steps there also. So A is usually, you might have learned this one, P inverse P D P inverse. Okay. So how to form that? P vector is like, it is a combination of the two eigenvectors. Okay. It's like a matrix formed from two column vectors. So it's like you'll be getting like 2 minus 2 and 3 1. So it's like this is similar to B itself. Hmm? Then the next one is D. So what is D? D is formed with the eigenvalues. Okay, matrix formed with the eigenvalues. So eigenvalues are given as, it's like a diagonal matrix formed with the eigenvalues. So I have, this is D. Then we want P inverse also. Okay, so let it be there like that. Okay, so from here you can see that anyway B equal to P. Okay, this is there, that relation is there. So if you put like mm, P inverse P, so if you know that what is like, you want to find, if you want to find uh, B inverse A B, hmm, B inverse is like P inverse only. Okay, so B inverse is like, so let me just clear everything, or okay, let me just put here B inverse AB we have to find. So B inverse AB is like P inverse, A is like P D P inverse, and B is like P. Okay, so if you see like this and like this is that line actually. So you can see that it is equal to D. Okay, so B inverse AB means that it is equal to D. Okay, so this is that question. Computation of that is equal to 1002. So the option is like um, option C. Okay, this is the option. So is this question clear? PPT I'll be giving. Okay, so yeah, if it's clear, then we'll move on to the next question. Okay, so how many solutions does a system of linear equations, these two equations, have? Okay, so you can just write this as in this form. Okay, we'll just write in the form of certain matrices. So you can just tell like this 15x, it's like 15, 20, 25. You can write, and 21, 28, and 20, sorry, 21, 28, and mm, 35. Okay, sorry. So can you tell me what is the problem here, or can it have how many solutions can it have? Infinite number of solutions. Okay, so why can it have infinite number of solutions? I've written the answer there, but still just asking, which all things are linearly dependent? Can you tell the relation? No linear dependencies. Why, Sandeep? Can you just simplify this like this? Like the first row will be, if you take the common from there, yeah, it's linearly dependent. So first row, if you take the common from there, it's like, how will you get that? 3, 4, and 5. And in the second row, if you take common 7 from there, there also you will get 3, 4, 5, right? Just simply, so if you see that both the rows are linearly dependent. Okay, so immediately you can tell that. Sandeep, is it clear? So immediately you can tell that these are linearly dependent rows. Yeah. So it can have given system of equations. So it's like x1 equal to x2. So it can have infinite number of solutions. Okay. So I think it was this system of linear equations and all was clearly discussed in the week 2 sessions. Okay. You can just go through that. Now the next thing is, given the matrix minus 31, 12, 12, 13, 12, 14. So the eigenvectors are, okay. So can you tell me what are the eigenvectors? How do you find the eigenvectors first? Can you tell me how do you find the eigenvectors? First is like you have to find the characteristic equation. Okay, so characteristic equation is like determinant of a minus lambda yeah, a minus lambda equal to 0. Okay, so if you solve that, it is coming like this in this form. Okay, so I think the operations are clear to you. Yes, so the equation will be coming in this form. Okay, lambda square plus 17 lambda minus 78 equal to 0. Then if you solve this equation, then you will be getting first eigenvalue as 17 and second eigenvalue as minus 34. So vi, we will, anyway you can take it like x1 x2, you can take like a vector, or you can take an eigenvector, assume it to be xy. So in this case I have taken xy. Then we have to substitute the eigenvalues in the equation. It's like a minus lambda I, whichever is your eigenvalue, into lambda I into your vector, whichever you have taken. Okay, that equals to 0. So if you solve this for x and y, then you'll be getting the eigenvector. Okay, so These are the options actually. So if you use minus 34 as your eigenvalue, then you will be getting minus 4 1 transpose as the minus 4 1 as the eigenvector. And if you are using the eigenvalue 17, then you will be getting 1 4. Okay, so this is how the eigenvectors are found out. Okay, so is this clear? So I think everyone's clear. I'll move on to the next question. Okay. So consider the matrix A. So you can see here, you can see the basis. The columns of matrix A forms the basis for the null space of another square matrix B. Find the rank of the matrix B. Okay. So you are given a thing here. Hmm? So anyway, it's the number of rows are here as 5 and number of columns are 3. So anyway, the rank can come even if the rows and columns are linearly independent. The rank can come only up to 3. Okay, depends on the number of rows and columns also. It's not a square matrix. So the rank of the given matrix is 3. Okay. So since if you try to form a basis for this matrix A, then and since the columns of this matrix A is forming as the null space for B, the nullity of B will be like 3. Okay, so the null space of B, so how it is like the null space of B of Y should solve the equation By equal to 0. Okay, so since like it is formed, so the basis of B is of the size 5 cross 3 and B is a square matrix. So basis is formed from the matrix A, so it will be coming like 5 cross 3, and B is a square matrix, so its size should be anyway like 5 cross 5. Okay, so you have a matrix which is having like a 5 cross 5 dimension, so its rank, it will be like B matrix. Okay, so it's like having linearly, it's going to be formed with linearly um, dependent and independent rows. Okay, so you want to find out what will be the rank. Okay, so you know the square matrix dimension is 5 and nullity we have defined as 3 because it is formed from the A matrix. Okay, so the rest will be like the rank. Okay, so if nullity is 3, there will be like 3 linearly dependent rows or columns. Okay, so the result you'll be getting like rank will be 2. Okay, so the rank of the matrix B will be 2. Okay, so I hope this is clear. Okay, I'll wait for a moment. If it's not clear, you tell. Okay. Okay, so, so okay, whoever is in the meeting, you keep your mics muted and your cameras also switched off, right? Okay, make sure that there are no disturbances. Okay, so I'll move on to the R solving in R. So we'll see some equations first. So the next one is like we'll move on to the R studio part. Okay, so just okay. So I'll just move on to R, and we'll just see how the different things will be seen. Okay. So first we'll see the simple operations like R program to add two matrices. Mm, so the first one is like I'll be creating two matrices. Okay, first matrix B and next matrix is like C. Okay, so n rows and columns all like earlier itself. Okay, so if I run this particular equation, statements, then you'll be getting C matrix then B matrix. Okay, so my chat keeps going on to the other side. Okay, uh, it's fine. So it's visible. The R Studio is visible, right? Our page is visible. Or do I have to increase the size or not? Okay, okay. So yes. So first, what we'll do is like getting the number of rows and columns. Okay. So number of rows of B, you can calculate like n row of B. Okay. Then number of columns, n row in column of B. Okay. So if you type like this, then then number of rows will be like coming like this, number of columns will be coming like this. Okay, now this is the first thing is like to program to add two matrices. So you can just put it like this: sum equal to B plus C, n row equal to number of rows, and column equal to number of columns. So this one is like first thing is like you can do it like using a for loop. Okay, so how can you do it with a for loop? I'll just copy the one for loop there. Okay, and we'll just see how to do it. So first I'll do like a sum matrix which can print this one, and then I'll be doing like for each of the elements separately, we'll see how the sum addition can be done. Okay. So right now we have stored the number of rows and columns in this one. So we have creating a sum matrix like this. So if you just like if you see what is sum, you can see that it's an empty matrix with the number of rows and columns of M. Okay. Sorry, of B, and then I'm just putting a for loop like row in one to number of rows and column in one to number of columns. Then it's not difference, sorry, since I copied from there, sum of row comma column. So for each element it will be like B of row comma column plus C of row comma column. So if you do like that, this is will be the sum. Okay, so I'm just printing the original matrix B and C as well as the sum also. So if I do that, you can just see here B matrix is like 1 3 5 2 4 6, and C matrix is like 7 9 11 and 8 10 12. So the sum will be like element wise summing. Okay, so it will be coming like 8 12 16 and 10 14 and 18. Okay, so this is like element wise sum. So there is another method also. You don't have to do a for loop or anything. So the next one is like using the plus operator. You can directly do like creating first matrix and second matrix like this. So in this case, I have just given a difference here. It's like I have given B like a column matrix, sorry, a complex matrix with complex numbers. Okay, so you can see here complex, and if you click this one you can see how it is looking like. This is the matrix complex matrix having complex values. C also I'm creating a matrix like that itself. So here also it is changed to complex values here. Okay, now I am just printing the resultant matrix just like P plus C. Okay, so here also you can see you don't how it is looking like here. The B matrix, I'll just print B also here. Sorry, I'll print in the console itself. Okay, so in the console, if I put B. B is coming like this, and C, yes, and D plus C. Okay, so how it is coming? You can see 3 when B plus C was done. Okay, so this is B and C. Yeah, then this one. Okay, element wise it has done. Okay, just can compare how it is looking like. Okay. Now the next one is like through the other one. Subtracting two matrices. I'll just go directly. Okay, I'll just print the whole thing. Hmm. So here also, like earlier, I'm just putting a for loop. Okay, so the same operation comes there, like element wise. This is one method of doing it. You don't have to go this much detailed also, because you can just put b minus c also. Okay, so if I run this one, then the whole thing will be run. And if you are printing, if you are putting like print of, if we have stored right now the difference, so if you are printing it, you will see the difference of the two matrices. Okay, so that is also fine. And directly you can just do like this also, you don't do a for loop. So for this one I'm just seeing like this. Okay, I'm just putting like a different method to show a different type. Okay, now we'll go on to the matrix multiplication. So for that also, I'm just feeding in the two matrix values, b equal to 1, 3, 1, 2 plus 3i, 5.4, and this one also, c also like that. It's first done earlier also, so I'll just show it here. And can you tell me what will be the answer if I run this particular thing? What will be coming if I print B star C? What kind of multiplication will I be getting? Yes. Okay. If you want element wise multiplication, then you should be doing like a simple star. Okay. So if I am just trying like this one, okay. So how should I put for normal matrix multiplication? Can you tell?
Percentage and asterisk and then percentage.
Yeah. So in this particular example, what will you get if I do that? Can you tell me what will I get if I run this one? You can just see the matrices here. Okay, this is C matrix and this is B matrix. Okay, so if I just put B percentage star percentage C, can you tell me what will be happening? Will I get matrix multiplied B and C?
Well, it will be a single value.
Hmm. How will matrix multiplication look like? Okay, let me just see like what you should be having. Sorry, I don't have to go there. Okay, so can you tell me like here, what is the what is the dimension of this B matrix? This is like 1 cross 3, right? And this is also 1 cross 3. So if you put 1 cross 3 multiplied with 1 cross 3, is it okay with matrix multiplication?
No, ma'am.
Yeah, it won't be okay. It will show you an error. The error will be like non-conformable arguments. Okay, it will be coming like that. Hmm? So any method by which you can create that? I mean,
Then we will transpose the C matrix.
Sorry.
Then we will transpose the C matrix.
Yeah, yeah, that you can do. If you do the transpose, you can solve it. Okay. So right now, if you run this one, you will be getting non-conformable arguments. Okay. Now this is also just simple element-wise division. Okay. So if I run this one, sorry, if I run this particular thing, then you will be getting like this. Okay. B by C will be getting like this one. Okay. Now, so let's move on to the next one, matrix function. R wants the data to be entered with column starting with column 1. So I'm just putting like this format it has to be entered. Can you show me the rank of matrix in, yeah, that I can show you, it's coming. Okay, Aditya, it's coming. Hmm? So you have to install some packages, I'll come to that. Okay, so A equal to matrix of this one comma 3 comma 2. So I'm just putting this as a matrix. So if you put like is matrix A, then it will show true, and is vector A, then it will be showing false. Okay. Now just um, mm, I'll just go this rapidly. So if you have to multiply by a scalar, then you have to just put C like a scalar, and then 3 cross A will give you multiplication by a scalar. Then, so next one, matrix multiplication. So it's less just like repeated only. I'm just showing this.
It will be necessary to assign the scalar in variable, then multiply the matrix.
Um, didn't get you, Phoenix.
Then is it necessary to assign a scalar in a variable and then multiplying to the matrix, or we can directly multiply matrix by scalar?
I didn't understand. There will be some operations, right, where you want to, yeah, there will be some operations, right, there where you want to multiply some scalar with matrices. So in that cases, you can use this. I didn't understand what you were using. Just type in the chat window, okay? Okay, I'll just check that later. So, okay, so Phoenix, are you typing or can we directly multiply the matrix by scalar? Oh, oh, like that. Okay, okay, okay. We'll see. Mm, okay, can you see here? Phoenix, are you fine? I mean, yeah. Okay, so I think, yes. So then the matrix cross product. If you want to find the cross product, then, okay, I think, yeah, this and just run once more. So if you want to find the cross product between A and D, then you can to use this command. Okay, so what is the cross product? Can you tell me what is the cross product? Type, you can type in the chat window. Okay. I have written there also. Okay, sorry. So don't. Okay, okay. Yeah, just that is like transpose of A into cross product. AD means transpose of A. Okay, transpose A, just write like this. So transpose, you'll find like transpose of A into matrix multiplication only into, sorry, into D. Okay, that is cross product. I've written there also. So that is cross product. Okay, if you want to multiply the transpose of a of a matrix with another matrix, that is known by cross product. Okay, so for cross product you just have to type cross prod of A comma D. If you type like that, it's coming like non-conformable arguments. Okay, so why is it like that? This is A matrix and D matrix. Okay, sorry. Um So just wait a moment. Mm, okay. So can you tell me why is, I mean, just D and A I'm just viewing right now. So can you tell me why is it cross product is not working here?
Ma'am, because the dimensions is the problem.
Yeah, yeah. So when I put like A transpose, now right now it's like 3 cross 2. So transpose will be like 2 cross 3. So 2 cross 3 multiplied with 2 cross 3 is not possible in matrix multiplication. That's why I'm getting non-conformable arguments. So you can just see like, okay, for example, I'll just copy this, and just before this one I'll just make it like 3 comma 2. Okay, we'll change the dimensions like that, and now we'll see what is happening. Okay, so now if you give it like that, the cross product is working. Why? Because right now A is 3 cross 2 and D is also 3 cross 2. So when you take the transpose of A, it will be 2 cross 3, and D is already 3 cross 2. Yeah. So what about dot product? What is usually dot product? What do you mean by usually dot product? Are you typing?
He might be confused in the cross product and dot product.
Okay. Soundarya, you can unmute yourself and ask. Just if you want to see, okay. So, okay. That one, I think you can just try like this one. Okay. So, let me just see. Is that the command? Dot. Yeah. But for that, yes, I'll just show you. So which one to try? Comma D will be try. We'll try. Hmm? So this is the dot product. Okay. But I'll be coming to that because directly you won't get it. You need to install a package. Okay. Like Pragma. Okay. So it's there in Pragma library. Okay, Soundria, is this clear? Yeah, so I'll be coming to that later. Okay, so okay, so this is like round. Okay, yeah, so we'll move on. So where have we stopped? Yeah, so just cross product AB, then transpose if you want to find like this. Then if you want something else, like if you want to find A multiplied with transpose of B, then you can just put like this, T cross prod of A to B. I think that is self-explanatory. Okay, so why didn't it come? Because again there is some problems with the matrices. Okay, so that you can try work around. Okay, now power of a matrix. Okay, so power of a matrix we had already seen in one of our um, assignment questions. So if you want to see how to find the power of a matrix, you want a library for that. Okay, so first I'll just put a matrix like this. So A is right now 10, 8, 5, and 12. Okay, now for that I want to install this library. Okay, so expm. If it's not there, then you have to install through this one. Okay, and put expm. Okay, that library you have to install. So now I have already installed this one, so I'll be just loading the library. Okay, so okay, so right now, yeah. So just we'll see, because some other dependencies are causing some problems or not. We'll just look at that. Did you? Sorry, wait. Kang, Kankna, I'm not sure if I'm pronouncing it right. So how many libraries? The libraries you can understand only when you are running different programs. Okay, sometimes whenever you have installed some libraries itself, some cases it might get last, I think last time also I had told, sometimes if your version is getting updated or something, or if the libraries are getting updated, sometimes you might have to install it again and again. Okay, so you can't tell like how many libraries you need to install. It is like when you are putting, whenever you are seeing for some new um, library, sometimes you have to install that. So then, I mean, you have to go and install that only. So that time only you can know which all libraries are needed. Okay. I don't assign the questions to you, Phoenix. It's taken care of by another team. Okay. So right now, um, yeah, if we want to do the power, this is one method. Okay, using that library expm. So if you want expm, if you are using expm library, then you have to do like this: a percentage asterisk percentage 2. Then if you see, a is like this, and a square is like this. Okay, so that is in that case. Now there is another method also. You can install this particular matrix known as matrix calc. So if you install this particular library, then the syntax is different. It's like matrix dot power a comma 2. Okay, so it will give you the same answer here. Okay, the both are different libraries and the syntaxes are different. Okay, but it will give you the same result. All right, so you can look at these two libraries for finding out the power. Okay, now, so I think I have put the console down. Okay, so okay, yeah. Now, so yeah, this is just at matrix A. So there you had some question like a raised to 4, a raised to 5, get the difference of that. So that question was there in the assignment questions which I have shown earlier, no? So I think it is like, yeah, that is this question. So for that, you can run this particular thing. So you want to find A4, so you can put like this one, and a raised to 5 like this. Then I'm just putting the difference in another variable, and then determinant we had to find the determinant of a raised to 5 minus a raised to 4. So just put like det is the determinant command to find determinant. So I'll just run this one. If you do like that, then you are getting, oh sorry, there is one small problem here. So let me see what is the problem. Yeah, this is in this case, okay. Yeah, I haven't this our a is right now, where is a, so our a is right now this one. So like a raised to 5, if a raised to 4, if I'm doing, or a raised to 4 is coming in this way, just we'll see. A raised to 4 is this one, and a raised to 5 is this. Okay, it's different from your question earlier. So then now if you find the determinant, it's getting a big value. Okay, so that is in power. Do we have to power in power? Do we have to take the power of determinant in matrix? No, this one is like so a square is like a matrix into a matrix matrix multiplication. Okay, so a raised to cube is like matrix A multiplied with matrix A into matrix A. Is that all right? Yeah. Okay. Now, yeah, inverse of a matrix. So to find the inverse of a matrix, this is one method. Like you can just put solve of A. Okay, so for right now, our A matrix is this one. Okay, so if you want to find the inverse, I mean, you can normally find it like one by determinant of A into adjoint of A, like that. Or in R, you can use this command solve of A. Okay, so if you just run this particular thing, you'll be getting the inverse of A. Okay. Now the solve function, it's not just used for finding the inverse. You can also use to solve a system of equation if you want to. If you want to calculate the solution for ax equal to b. Okay, so x you don't know what is, I mean my x1 x2 something for a 2 cross 2 matrix. So if you want to just solve for ax equal to b, then you can type solve. Okay, so just I'll see if b has been loaded. Okay, b is not there, so I think I have missed to load b. Okay, so we'll take this a and b. Okay, so yeah, so then we'll move on to just solve for that. Okay, solve, if you put solve a comma b, then you'll be getting the x values like this one. Okay, so ax equal to b, a you have defined, b you have defined, then the other things will be like this. Okay, the x values will be like this. Okay, then I think someone has asked for rank of a matrix. Okay, so the rank of a matrix, you know, it's like the maximum number of columns or rows that are linearly independent. Okay, so what you can do is you can use the QR function. Okay, or there is another options also. So just if you just put like QR of A, if you put, then you will be getting these many things actually. Okay, so it will be like, it will be having one thing as rank. Okay, so this is like, um, if you want to see more of that, um, okay, I think you have to go for the help option. Okay, anyway, but it's not needed right now. Then there is another option. So if you want to get just the rank, then QR of A of rank you can type, and then you can see the rank for the matrix. Okay. Then again there is another way also. So then if you are um, using this, that is another thing. Okay, I also have to look Phoenix QR of other things. Okay, so you can also search that. Hmm? Yeah, so the another library is like library of metrics, that if you are installing that, then you can use this particular command. Okay, rank matrix of A of 1. Okay, it will tell you the same thing. Okay, now there is other things like diagonal. If you want to make a diagonal matrix using these values, then you have to just put diag. So these are all working because this library is now currently installed. Okay, that is there, that's why. Then eigenvalues and eigenvectors in R. If you want to find out the eigenvalues in A, sorry, wait a moment. Eigenvalues in A, then you have to put like this, and you'll get the eigenvalues as well as vectors. Okay, so these are the eigenvalues, and these are the eigenvectors. Okay, now if I am putting like this, okay, so if you want to see just the eigenvector, then eigen of A, then you put dollar and then values, you will get just the values. If you put eigen A dot vectors, you will get just the vectors. Okay. So I think you can just go to this. I have just put this one. Okay, there you can find more information on the different operations that you can do with R. So right now, what I'll be doing is like just some questions were there which were related to our session right now. So I have just created like inverse of a matrix. I think there was one question for, sorry, inverse of matrix. Yeah. So if you want to do that, then matrix 4 is given like 1 3 5 2 6 10 and 3 9 8. I have also put like this 1 3 5 2 6 10 3 9 8. Number of columns I have given like 3, and I have put by row equal to true, so that it should be going row wise. Okay, now so creating seeing the inverse is like you can use the solve function. So I'll just solve, so you can see the system is exactly singular. Okay, so you can remember from the question what was the problem here. The problem was that there were,
Ma'am, the columns were
First and
independent.
second are independent.
yeah, it was dependent. So when we run the same thing here, it's like system is exactly singular. Okay, so you can find the inverse. Now the next one, finding the eigenvectors. I think that was question um, okay. This question. Yes, so to find the eigenvectors of the question. Okay, so minus 31, 12, 12, and 14. So I have given like number of rows equal to 2, number of columns equal to true, and by row equal to true I have put. Okay, so to find this I'll just load here, and just we have to find the eigenvectors. Okay, so eigenvalues first we'll see. So there is a difference here actually. So it can have, since it's like it's coming like some many solutions will be there. So when we are solving like this, it's like k into minus 4 1 and k into 1 4 will be coming here. So in that case we were looking getting like this. But when you're solving in this form, The eigenvalues are coming like same only. So we were getting like 17 and minus 34, but the eigenvectors they have calculated in this way. Okay, so you can have many solutions for that. Okay, now since it's like you had solved this like for example you are getting like one constant into minus 4 1. If you just solve you can find that. So whenever that constant is changing you will be having different values. So r, if you are doing r to calculate this one, the answer is coming in this way. Okay, now there was another thing. Yeah, yeah, so this is so last time I have just shown you another method. Okay, you can use the qr library also. Okay, qr function, it's like qr decomposition actually. So in that itself, okay, so it's a different operation in a matrix. So in that itself the rank was present. So if you are putting like qr of a dollar rank, then you could get the rank itself. Okay, so there are many other things. So it's like a different operation there. So Phoenix also has asked, I think you can search for that. Okay, um, right now it's a little out of the scope, so you'll see that later. So if you want to find just the rank, there is also another method. Okay, so right, I think you have just asked. Okay, so someone has asked, so rank directly you can do, but the problem is this library should be installed if you want to type rank of a. Okay, so just I have already installed, just wait. So I'll just run this one. So this is like matrix A. Again, it has changed like this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not by row. So it's coming like this. Okay. Now I'll install this library. So the library, I mean, the library is already installed. I'll come bring it to the environment. And then if I put rank of A, that will be working. Okay. So this is another method for finding. So there are many methods to find out rank. You can use QR. Okay, QR of A like that. You can use rank metrics if you have installed library metrics, and you can use rank of A if you have installed library pragma. Okay. Now another thing, dimension of B you can find. So I think B is not given here anyway. So just okay, B is not created here right now. So I'll just run some other B. So this is B, and if I just put dimension of B, it's coming like 2 cross 2. Okay, so I think that is all for the second week assignment in R. Okay, we'll slowly move on. I think we have a 13 minutes time also. So till now, if you have any questions, you can ask, or I'll move on to the week 3 assignment. Okay, if everyone's okay, just put okay in the chat window so that I can move on to the next one. Okay, so let's move on to week 2. Well, sorry, week 3. I'll be sharing the week 3 files later. Okay, so the week 3 is loading right now. Okay. Hmm. Okay. So I think there is some problem in loading. Just wait for a moment. I'll just see. Okay. So wait for a moment, everyone. So I think I can share from the command from here itself. Just wait for loading it. Some problem has come. Um, taking some time. Okay. Mm, so I think I'll just share with the assignment question itself. So let's just load that. Okay. So it's not opening. So I'll just okay. I'll do one thing. I'll just share some other PPT. Okay. So just first it'll be starting with what all are the different things. Okay. So I'll just share now. I'll share the window now. Mm, okay. So you can look at this. Sorry, Aditya, to find trace. Okay, trace you can just do like uh, tr of metrics. Okay, okay. So week three contents, I think you have gone through. Like it's like random phenomena, then hypothesis testing. All those things are coming. So they'll just simply go through that and maybe we can see them in the next session. So random phenomena, do you know what is that? A phenomenon or experiment whose outcomes are not predictable with certainty are called random phenomenon. So in that sample space is there, the set of all possible outcomes of an experiment, the sample space, and event is like any subset of a sample space. All right. Now just next one is probability. So probability, every one of you know that it's like a measure that assign real value to every outcome of a random phenomenon. So it's like number of E by number of S. So wait now console the different notions and directed of then I have to check that Phoenix method to change permanently. I have to check that. I'll get back to you next time. Okay. Method to I think for me it was like directly in the permanently it was there in the um, place, I mean the directory which I was opening. So I haven't experienced like this. Okay, so let me see, I'll tell you. Okay, so just wait. um, yeah, so okay, that I'll do. Then so if the some axioms of probability is like 0 less than or equal to p of e less than or equal to 1, so probability is non-negative and less than 1, then probability of sample space is 1. and probability of A union B equal to P of A plus P of B if they are two mutually exclusive events. Okay. Now, so out of all the possible jumbles of the bird, you can like just see like what's the probability that it will start with P. So I think you all are familiar with this one. So all possible jumbles of the word bird will be like, there are no repetitions. So it will be like 4 factorial. So 4 into 3 into 2 into 1. And the number of events there will be like the ones starting with B. So you can see here B like this it is starting. So BIDR, BRID, like that many options are there. So it's like you are fixing one position there, and then the other three positions are have the chances of getting filled 3 factorial times. So you can just put like number of events will be like 3 factorial, and number of sample space will be like 4 factorial. So 1 by 4. Okay, so these things and all are present in your um, week 3 resources. Okay, so you can just go through that. Then events like mutually exclusive event, occurrence of one event implies that the other event does not occur. Okay, so yes, so these are two mutually exclusive events. You can see coin toss. So it's like either a head or a tail. Okay, not both will be coming. And independent events is like two events are independent if occurrence of one has no influence on the other. So locating, landing on heads after tossing a coin and rolling a 5 on a single six-sided die would be like independent events. Okay. Now these are some Venn diagrams. So first one is like the colored region I mean E union F, then E intersection F. Yeah. So then E complement is the colored region. Then F is like inside E. So F is like a subset of E. Okay. Now conditional probability is also there. So if two events A and B are not independent, then the information available for the outcome of event A can influence the predictability of event B. So example is like if two fair coins are tossed, then first toss is head, second toss is tail, or like HH can come. So probability of A is like number of A by number of sample space coming like 2 by 4. There are 4 chances. So zero point 0.5 will be coming. Now two successive heads if they are coming like HH will be one of the events. So n of b by n of s equal to 1 by 4. Then if the event A is given, then the probability of event B is P of B given A equal to P of A intersection B by P of A, it equal to 0.25 by zero point 0.5 equal to zero point 0.5. Okay. Now random variable. Hmm? So random variable is mapped from sample space to a real line such that there is unique real number corresponding to every outcome of a sample space. So there are discrete random variables as well as continuous random variables. So a variable that takes one value from a discrete set of values is like a discrete random variable, and the variable that can take continuous range of values is continuous random variable. So examples are like dice rolling, you have 1, 2, 3, 4, 5, 6, and another one is like temperature of the week, which can have any some continuous values. Okay. Now the next thing is like probability mass density function. So yes, so first one is like probability mass or density. So probability mass function, it's used for discrete random variables. Then it's like p of x equal to x. Okay, so for each of the instances you can see, then there is probability density function which is used for continuous random variable. Okay, Yeah. So the next one, just I have 20 defective items and 18 non-defective items, as total sample space will be having like 100. If two items are selected at random without replacement, what will be the probability that both items are defective? Okay, so this is like 100 is the total, 80 defective, sorry, 18 non-defective, 20 defective. So if the combinations are like 100 C2 is the whole thing, then 20 C2 from the defective, and 80 C0. Okay, then if we are doing like that, then we'll get this kind of probability. Okay, so that is okay. So these, anyway, these things are all there in your resources. Just I'm just before going on to the problems, I'm just rapidly going through everything. So distributions, you can see that there are binomial distributions as well as Gaussian distributions. This is the equation. Okay, so p of x equal to ncx p raised to x q raised to n minus x. That will be like n is the number of trials, x is the number of successes, p is the probability of getting a success in one trial, and q is 1 minus p. Then Gaussian. So Gaussian is like, distribution is like, so if it's between a mu, I mean between 1 sigma, for 1 sigma values you'll be covering like 68.27% of the whole values. Between 2 sigma you'll be covering 95.45, and 3 sigma will give you 99.73%. Okay, this is the equation. Then you have the statistical sampling and hypothesis testing and all. So there, population means the set of all possible outcomes of a random experiment. So this is like the population, and if you are collecting some set of observation from that, it is like the sample. So sample set is like finite set of observation obtained from the experiment. Samplings helps to make the inferences about the population, and inferences may be uncertain because the samples might be uncertain. Okay, so just a moment once again. Mm, I'll just see this. Okay, so let's try to um, get the thing again. So mm, so wait a moment, everyone. Just like trying to recover the file. Okay, so yeah, it's there. Okay, so I'll just share once again. Let's go right now. Mm, okay, so I think we have seen the yes, okay. So statistical analysis can be descriptive and inferential. Okay, inferential means like estimation or hypothesis testing. I think you have seen everything there. So graphical statistics means whether you'll be seeing like a scatter plot or a histogram. So some examples are given here. Then scatter plot is like you'll be getting many different like values based on the observations that you're getting. Histogram will be like there will be a range of values for the x-axis. So for example, it will be from this range to this range. So you'll be grouping your variables into different boxes, okay, like different ranges, okay. Then the box plot is like, I don't know if you have can come across this. So this is like maximum values will be represented here, minimum values will be represented here. Then this will show how much percentile of your data is lying in a particular uh, region. So the median will represent like 50 percentile of your observations are lying there. Okay, so this you can, if you are having any doubt on this, you can ask later. Okay. So then numerical statistics, this you also you have seen earlier, like mean, median, mode, range, etc. Okay. Then covariance and correlation. I think these two things have some questions there in the assignments. Okay. So covariance is like indicates the direction of a linear relationship between the variables. So covariance values are not standardized. You can find covariance like this. Okay. Now, correlation means like it measures both the strength and direction of the linear relationship between the two variables. Correlation is like covariance of x comma y by sigma x into sigma y. Okay. Now, hypothesis testing. This is also present in your week 3 slides. Okay, so just I have put like hypothesis testing is used when we want to make some decisions. Like, for example, whether the effect of drug A is similar to drug B. If you want to find that, then you can use um, hypothesis testing. So, hypothesis testing is generally converted to a test of mean and variance parameter of the population. So, there are like two-tailed hypothesis as one-tailed hypothesis. Okay, so this particular portion will be like do not reject the null hypothesis, where you're telling like some particular value is equal to this one. And if it's like you're telling mu is not equal to 23, then it will be like a two-tailed. Okay, it can either go in this way, the left side, or in the right side. And if you are specifying like mu, your null hypothesis as greater than or less than, then it's like one tailed. Okay. Now, null and alternate hypothesis. So, if the null hypothesis is like application of biofertilizer X will increase the plant growth, then the alternate hypothesis is like is the hypothesis which is the researcher is trying to prove. Okay, in this particular case. Now, H0 is the application of biofertilizer X that will not increase plant growth. So H0 here is like null hypothesis, which the researcher is trying to disprove or nullify. Okay. Now there is the type of errors. I think you have seen the same thing in the your week 3 resources itself. Okay. So if H naught equal to true and H naught is not rejected, that is one correct decision. Similarly, if your alternate hypothesis is true, and sorry, here it's H1, okay. If H1 is true and H1, I mean H naught is rejected, that means like H1 is accepted, that is also a correct decision. Okay. Now, in some case, it's like H naught is true and H naught is rejected, that is like type 1 error. It's in a type 1 error probability. Alpha is also known as the level of significance of the test. Okay. And type 2 error is like the alternating hypothesis is true, but H naught is not rejected. That means like alternate hypothesis is rejected and null hypothesis is accepted. In that case, type 2 error comes. Okay. Now, these are some questions. Uh, so, do you want to continue it now or later? I can take some questions now, or we can see it later. Okay, so some more questions I'll see now. So Yeah, so let x and y be two independent random variables with variance of x equal to 9 and variance of y equal to 3. Find variance of 4x minus 2y plus 6. Okay, so this is like, I mean, you can use this relation here. Okay, so it's like, mm here right now we have like variance of ax. So in this case, in this particular case, um, a is 4, so you have a relation like this: variance of ax plus by plus c equal to a square into variance of x plus b square into variance of y. Okay, so this is a, this is b, and c. So you can just put like a square is equal to 16 and b square is equal to 4. So a square into variance of x. So it will be like 16 into variance of x is 9 plus 4 into variance of y is 3. Okay, so you'll be getting the answer as 156. So the right answer will be 156. Okay, now the next one. Calculate the standard error of a sample mean using the following data: n equal to 14, mu equal to 18.5, x bar equal to 17.85, and s equal to 1.95. Okay, so the number here is right now 14. Okay, you want to see the standard error. So standard errors usual equation is like, it's straight away the application of equation only, s standard deviation here by the root of n. Okay, so the standard error of sample mean. Okay, we have to calculate. So like mu is the population mean, x bar is the
Ma'am,
sample.
what is S here?
Where, which one? S is like the sample
What
standard
is
deviation.
S 1.95?
Sample standard deviation. Mu will be your population mean. Sigma will be your population standard deviation. And x bar will be like sample mean. I'll write that. Okay. X bar will be like sample mean. This is usually this is the representation. This will be like population mean, and this will be like population standard deviation. Okay, sigma, and then here right now s is like sample standard deviation. Okay, so the standard error usually will be like, we are used to calculate the standard error of the sample mean. Okay, so that's why we are using like s by root n. Okay, is that right?
Yes, ma'am.
Yeah. Okay, now next one, this correlation coefficient of two random variables x and y is minus 1 by 4. The variance are given by 3 and 5. Okay, so right now I have written here, who has raised the hand. You can unmute yourself. Okay, okay, let's continue. So what is given there? Like correlation coefficient is given, r of xy is given like minus 1 by 4, and variances are given: sigma x square equal to 3 and sigma y square equal to 5 is given. Okay, so you know this relation. If you want to find out covariance, okay, what you have to do, so this relation is, you are having like, um, r of xy, okay, equal to covariance of xy by sigma x into sigma y. Okay, yeah, so from that you can get like covariance of x comma y. It is given as 14 in question. Which one? um can you tell me what did you mean by that? It is given by 14 in question.
Ma'am, it is given as correlation coefficient of two random variable x and y is 14, and the covariance is given by 3 and 5. Compute
This
the
is different
covariance.
question. This is different
The
question.
same
This is
options have been given. Okay.
yeah, yeah,
Okay.
yeah. You can try with yours. This is like previous run assignment. They
Okay.
had given like -1/4. Okay.
Okay, madam. Thank
Yeah,
you.
yeah. So yeah, the values will come changing. Okay. Yeah. So covariance of x comma y. Actually, we are not. We are asked not to discuss with the present assignments with you. So that's why I'll be discussing the previous assignments only. Okay. The present assignments you have to solve, but in cases like some cases it will be coming similar also. Okay. So that is this particular case has happened. Okay. So covariance of x comma y equal to r of xy. This is the method. This is the step. Sigma x into sigma y. Okay. I think it's like yes. So it will be like -1/4 into root 3 into root 5. Okay. Your answer will be like 0.968. Okay. Now, so from here onwards, I think we can check with the R things also. So the this is like each of these things you have to see how it is calculated. All right. Okay. So there will be t statistic, f statistic, then set score. All these things you have to see in your resources for the week 3 session. So this question it's like asked find the t statistics for a sample data given that the population mean of the distribution is 8. So it's given population mean is given here 8. Okay. And you are given just the samples. Okay. So in that case you can just calculate in this particular case what are you having. So x bar you have to calculate from your samples, right? Now mu you have. Okay, this s is the sample standard deviation and n you are knowing. Okay, so these things you should calculate from your data you are given, and you are given with the population mean also. So I think this process is clear with you. Okay, x bar is mean from
Ma'am,
these
X bar is
samples.
5.1.
Yeah, x bar is like average of these values.
It's coming out to be 5.1.
Yeah, it might be. Wait, is it written? Yeah, it's coming to be 5.1. This is the R code. I'll just go to the R session, okay? Mm, sorry. So I'll see with the R code also. This is the same question. Find the t statistic for the sample data given that the population mean of the distribution is 8. Okay, so here just if you see the average of this one you'll be getting 5.1. Then if you take the standard deviation, no calculation of standard deviation, like you have to minus the new values, then take the deviations, then like so that process I think you are knowing. Okay, so if you calculate the standard deviation you will be getting s in that matter, s for that matter, because population standard deviation is not given. Okay, so if it was given then the test you'll be doing will be different. Okay, in this particular case sample mean, sample standard deviation you have, and also population mean you have, so you can go for the t test. Okay, so R Studio, if you are going, just I am putting samples like this. So these were the samples which were given there. I will load that. So just I'll clear everything. Yes. So this is like samples of C. So samples is right now it's an array like this one. Then you can directly do like t dot test. Okay. There is nothing else required. Just what you have to see that. Anyway, in our question, samples were given and we have to provide the mu also. Okay, population mu you have to tell. So if you run this one, you'll be getting like this. Okay, so these are the different parameters which you can see in a one sample t-test. Okay, so right now they have calculated for a 95% confidence interval. These will be the variation in your values, and the mean of x will be like this, then the t value will be like this. Okay, so this is the t statistic. Now we'll move on to the next one. So t statistic value is coming like minus 8.33. Okay, now next one. Sorry, was it the fourth one we have seen? Yeah, so find the statistic for the following sample sets generated from the same distribution. So can you tell me why the F statistic was created here? What difference happened here? Do you have the population mean here? Do you have the population mean here? Mu is not available. Okay. Yeah, for usually most of the test packages is not needed. I think it will be usually installed. But if it's not, it's if in some case, if it's not installed, they'll be giving you like this particular function is not found. Then you can directly go and install. Okay, Aditya. Usually, I think it won't be asked. It has when I was running also, it was not asked. Okay. So right now what you have, two samples you have. So from samples you can find the as well as the x1 bar, and from this one you can find the x2 bar as well as s2. So s1 you have, s2 you have. Okay, so all these differences, then they are, oh, they want you to calculate the f statistic. Okay, so similarly the same thing itself. So sorry, I'm just running through everything. So I'll just keep this one and I'll show you. So these are the two samples which were given to us. Then you can just put like var dot test. Okay, because why? So it's like variances you are calculating. Hmm? So let's like this thing is like var dot test is used for the f statistic. Okay, so if you run this whole thing, it will be like F test to compare two variances. It is usually used to compare two variances. Okay, so this is your data, sample 1 and sample 2. Then F statistic value is coming like this one. Okay, then this is the ratio of your variances. Then the confidence intervals is like this. Alternative hypothesis is like 2 ratio of, what is the null hypothesis? Like S1 by S2 equal to 1. And alternate hypothesis will be like S1 by S2 is not equal to 1. Okay, so that is where you will find the F statistic. Okay, so I'm just checking. Now the sixth question is like find the F statistics of the following samples generated from the distributions with population variances are given here. Okay, earlier case there were no population variances given. But when you are given with the population variance, then what you have to do is like um, how to find it. Okay, so what can you do? This also I have just put find the F statistic for the following sample sets generated from distributions. Population variance is also given. So this is sample X and sample Y. Hmm. Then variance are also given there. Okay, so variance of sample X is equal to, I'm just putting like VAR of sample X. VAR of sample X means, um, sorry, this whole thing have been wrong. So sample X variance will be like this one. This divided by 3 will give you um, the value, and this one. So both the variances S1 by that new one, this one, if you take the round value also, you'll be getting like the F statistic. Okay. So that is another method. Hmm. Now, the next question. Okay, I think the time is near 1. Okay, I'll just move on. If you have any doubt, you can ask the next class. So, how will you reject the null hypothesis? Can you tell me? When will you reject the null hypothesis? Yeah. So, we reject the null value if v value is less than alpha. Okay. Yeah. Okay. That is some theory part. Then a standard normal density function is shown. The area of the shaded region is. Okay. So for these type of questions, you can just see. I mean, it's difficult for us to see in the studio because I mean a curve is just given like this, and it's given like mu is equal to 0 and sigma equal to 1. Then this is like theoretical. So immediately, if you want to find, I think you can just go and put this thing. Okay, if you can see here, and if you are just pressing, this is an easy tool to find out the value. So it's like if you are having just 0 to z minus 2, then this is the percentage. Another, I mean, the usual method which you will be finding is like you'll be checking here, right? So if it's 2, then one side it's like 0.774772, and your curve is like both sides are there. So it's like 2 into 0.4772. Then the answer will be like 0.477. What will be the answer? 0.4772 into 2. So it'll be like 9.954. Okay. So that will be the answer in this question. If you want to find it out easily, you can just check this link. Okay. Then the next one, a talent exam is conducted annually, which has a mean score of 200 and a standard deviation of 30. If a student's set score is 1.50, what is his score in the exam? So this is an easy question. Okay. So you are given the mean, given the standard deviation, and the set score. Okay. So I'll run these three. So you know now z is equal to x minus mu x minus mean by std. So x will be like, if you are given the set score, it will be like mean plus z into standard deviation. Okay. So the x value for the particular z score of 1.5 is 245. Okay. So that is a direct question only. Then the next one, a car company purchases engine blocks from suppliers A, B, C, B and C. Out of the 100 units supplied by A, 2 units were found to be defective, and similarly, out of 200 and 300 units supplied by B and C, number of units found to be defective were 10 and 15 respectively. So, if a quality control person of the car company picks up a block, and if its selected block is selected from block A, what is the probability that the block is defective? Okay, so you have three, I mean, different companies like that. Okay, so like for example, you have A, B, and C is there, and that total 100 units here, 200 and 300. Then defectives in that is like how many? 2 units. Okay. Similarly, 10 and 15. They were asking like number of probability of defective in A. So 2 by 100. Okay. Will be. So the probability that the block is defective if the selected block is from A. So this particular thing also I've just done here. A is 100, defective is 2. Then A probability defective is defective of A by A, and I have written that answer. Okay, so this is all for week 3 assignment also. Okay, is that fine? More thing is like you have to see the different test scores. Okay, so anyway, the time is also right now 9:10. So I think I'll be stopping the class today. Okay. So everyone have a nice rest of the day. Yes. So since like it's going to end. So